So the statements given here are all apples which are red are tasty. All apples which are red are tasty. Now this would be hard to draw in Venn diagram immediately. Let us first look at the other statements. So the second statement says most reds are apples. Now whether it is most or some or few or at least some, everything is same, right? I mean, most reds are apples does not mean that you will draw red like this and then you say most reds are apples. So draw apples in this fashion, because most is been given, right? So the point that I am trying to make is most does not mean that you will overlap a larger portion, right? That makes no sense at all. Most is also like some. You're getting it? So most reds are apples. How do you draw? Red here and apples here. Some reds are apple. I mean, most reds are apple is as good as some reds are apple, right? I mean, it's like some reds are apples. That's what it means. Then some balls are red. Some balls are red. So some balls are red. That's very simple, right? Some balls are red. So this is done. Third statement says most apples are balls. Most apples are balls. Okay, so I think we'll have to redraw this diagram here, because apples and balls also have to overlap. Earlier I did not overlap because we are drawing the basic diagram. But again here clearly it is given that most apples are also balls. So draw balls in such a way that it overlaps with reds as well as apples. You getting it? Third statement says some balls are red. Next statement says some apples are balls. So balls have to be drawn overlapping with both reds as well as apples. So third statement is satisfied. Some balls are red. And fourth statement is also satisfied. Some apples are balls. Some apples are balls. Now go back to the first statement. All apples which are red are tasty. See, so far we have covered these three statements, right? Most reds are apples. Some balls are red. Some balls are red. And most apples are balls. Most apples are balls. Now look at the first statement. All apples which are red. All apples which are red are tasty. Now all apples which are red is which section? This section. See, all apples which are red means what? Overlapping between apples and red. This region, right? So all apples which are red are tasty. That means this overlapped region, this shaded region represents tasty. You getting it? All apples which are red are tasty. So that's the diagram. That's what it means basically, right? This is the basic diagram. All apples which are red are tasty. So that leaf between red and apples is tasty. Now look at the conclusions. Conclusion number 1. Some reds are tasty. Now according to the basic diagram, yes, some reds are tasty, because this region which is shown by tasty, I can do one more thing actually. Instead of shading it out and all that, I can write tasty inside this leaf. It is the same, meaning is same, right? I mean, we can do this. We can say this is tasty. This is tea. Tea means tasty. You getting it? So that it looks like a regular diagram. Nothing new about it. So only this leaf is tasty, right? Only this portion is tasty. Now look at the conclusion. Some reds are tasty. Yes, it satisfies the basic diagram. Some reds are tasty. You see, reds. Some of these reds are tasty. And you are sure that it will always satisfy the diagram. I mean, any diagram you draw, because this conclusion has satisfied the basic diagram, you will now have to check the possible conclusions, possible diagrams. You're able to follow. This is like a definite conclusion. Some reds are tasty is like a definite conclusion. And you know that a definite conclusion is true only if it satisfies all the diagrams. So here, some reds are tasty has satisfied the basic diagram. Now, will it satisfy the possible diagrams as well? Yes. Any diagram you draw, you will always find that some reds are tasty. Why? See, the point is this. We know that from the statement, the first statement itself, all apples which are red are tasty. All apples which are red are tasty. So there are some red which are tasty definitely. Even without drawing the diagram, from the first statement itself, you can say that there is definitely going to be some overlapping between red and tasty. Because all the apples which are red are tasty. So these reds will definitely be tasty. So some reds are tasty is always going to be true. So the first conclusion definitely follows. Now look at the second conclusion. Second conclusion says what? Some apples are neither red nor ball. Now look at the basic diagram first of all. This is also like a definite conclusion. First one was a definite conclusion, second one is also a definite conclusion. And you know what needs to be done in a definite conclusion, right? First check the basic diagram, after that check the possible diagrams. I mean, if it satisfies the basic diagram, check the possible diagrams. If it does not satisfy the basic diagram, here itself you can say it is wrong. So read this conclusion. Some apples are neither red nor ball. Yes, some apples are neither red nor ball. I can say these apples, this shaded region you see, these apples are neither red nor balls. Yes or no? This region is neither red nor balls, or this region is neither red nor balls. This region is neither red nor balls, neither red nor balls. You're getting it? So basically we have some region of apples which is neither red nor balls. But will it satisfy all the diagrams is the question. It has satisfied the basic diagram, but will it satisfy all the possible diagrams as well or not is the question now. And if you are smart, without drawing the diagram, you can say that it will fail in other diagrams. So your answer should be only one follows. Now let me show you where it fails, right? I'll draw a possible diagram for this one. And possible diagram I'll draw in such a way that the second conclusion becomes wrong. See, what did it say? Most reds are apples. Some reds are apples. Most reds are apples is nothing but some reds are apples. So I'll say these are reds and these are apples. Reds and apples both are same circles. Then some balls are red. I'll say some balls are red is this circle. And most apples are balls. Most apples are all balls is also satisfied here. So basically what I'm trying to say here is reds, apples and balls are shown by the same circle. All three are shown by the same circle. Now read this conclusion. Some apples are neither red nor ball. Here tell me which apple is neither red nor ball. Are you able to follow? In this region, which apple is neither red nor ball? All the apples are red, all the apples are balls. There is not even a single apple which is neither red nor ball. So the point here is, though this conclusion satisfies the basic diagram, it fails in the possible diagram and hence it is wrong. So your answer should be only conclusion 1 follows. Only conclusion 1 follows. Remember, a definite conclusion should satisfy not only the basic diagram but all the possible diagrams, right? So only conclusion 1 follows is the answer and conclusion 2 does not follow. Conclusion 2 does not follow.